Hey there guys, we're moving along here in chapter 4. We're going to talk about relations and functions, dealing with function notation and what's going on. So first thing we need is some definitions, all right? So if you're going to be a relation, right, that is a set of ordered pair. Remember, an ordered pair is an x and then a y, all right? So normally it looks like maybe -3 with 2, something like that. So if I give you a set of ordered pairs, that's always called a relation. So the answer to everything today, if I say, is it a relation? The answer is yes, right? Because everything is a relation, a set of ordered pairs. Now, if I ask for only the x values, that is the domain, right? Those are the x values. The y values, those are known as the range. All right, just a little tip here. These are alphabetical order. D comes before R, just like X comes before Y. So if for some reason you're getting those confused or you just don't remember, just think of the alphabet because we have that thing down by now. You know what I'm saying? All right, so is it a function? Let's get some ordered pairs and let's build a relation. So let's go with 2, -3, 3, -5, 8, 1, and let's go with -2 with 1. All right, and I wanted to repeat something in here because this is one thing that sometimes gets confused from what you had worked with before. So is it a function? Before we answer that question, let's first make it into a map. So my domains, right, these are my x values. I'm going to go with 2, 3, 8, and -2. My range values, all right, so that's my y values over here. So I got -3, -5, 1, and 1 is already listed, so I don't need that again. All right, so first thing we'll say is 2 is paired with -3, 3 is paired with -5, 8 is paired with 1, and 2 is paired with 1. Okay, so as we start to evaluate if this is truly a function, we're going to have to look at this in very different ways. The first one is if we make a map, and that's what we have down here. This is called a map of the function. And the first thing I'm looking for is out of all my domains, do I have one arrow leaving each number? And if I can say yes there, then yes, this is a function. Okay, so that's probably the easiest test to look at. Okay, now let's take that idea and head back to the actual ordered pairs. I'm gonna look at my x values. I have 2, 3, 8, and -2. Did I ever repeat them? No. If I never repeat them, then yes, this is still a function. Okay. The catch comes in is, could I have -2 with 1 in there again? Would my -2 still have one arrow coming out of it? And the answer is yes. Okay, so we often talk about this when we have a full-blown long class to talk about everything, is we say it's kind of like going to buy something at Sheetz or McDonald's or whatever it is. Okay, so if I take any ordered pair, and I'm going to pretend that this one is positive, right? So let's say we're going to go to Sheetz. We're going to buy 3 hot dogs for $5. So I take my 3 hot dogs up there. They go boop, boop, boop. They scan all 3 of them. And they're like, all right, $5. I'm like, all right, great, right? Because that's the function of the register. That's what the register does. Now the next person up there, they get their 3 hot dogs. They go boop, 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 and it says $7. At that point, right, if I had 3 for 5 and then 3 for 7, right, there's something wrong, right? They got charged a different amount for the exact same thing in the exact same quantity. So when that happens, they call the manager and say, hey, the register is not functioning. So use that vocabulary, very intentional about what's happening. Okay, so that's an example of a relation, but not a function. So anytime repeat the x value with a different y value. Okay, so this one is 2, 1 and -2, 1, -2, 1. That's okay because that means we got charged the same price. Okay, so kind of a long-winded explanation, but hopefully something in there sticks. At the very least, we're all hungry for hot dogs now. Okay, so let's do this one into a map. All right, so I got 2, 3, 11, 8, 7, and -6. You're saying, hey, Mr. Tola, slow down. Where'd you get those? All I'm doing is going through the x values, right? All right, did I ever write the same number twice? No, right? Because it's a 2, 3, 11. All right, I had to write a domain for every single ordered pair up there. So is this going to be a function? Yes. Okay, yes, it's a function. Is it still a relation? Yeah, it sure is because it's a set of ordered pairs. All right, let me get my y values in here. So let me shut up for a second. 5, -2, -3, 4, 121. 121. Oh, my pen stopped for a second there. 121 and 0. So here's the first thing. This is the map looks like. Not very interesting, not very tricky, not very exciting at all. Right? So those are X's, those are Y's. Right? That's just one of the skills that we have. Remember the thing I'm looking for. Do all of these have one single arrow coming out of it? Again, yes, we confirm that it is a function. All right, so we'll challenge you so far. Can you add on an ordered pair that would make this not a function? Okay, so what would make it broken? Okay, so I'm thinking about buying hot dogs. Right, so I'm going to key in on an ordered pair like this. So I'm going to buy 7 hot dogs. They get charged $121. So let's say I only get charged $10. Teacher discount at the Sheets for buying hot dogs, right? Yeah, they don't have it. Just so you know, I already checked. Okay, so this would mean if I put these together, okay, does it pass the function test? No. Is there relation? So yes. So it might say relation only, okay, or we say it's not a function. Okay, don't get held up in the vocab. Right? If I say yes, that means it is a function. If I say no, that means it's still a relation, because remember, everything that we're going to deal with is a relation. All right, what's it say in your textbook? It says that each domain, x value, has one unique range value. Okay, it's unique meaning it's the only one. Okay, so let's take a look at something that may have happened at some point in your lifetime. Maybe you got a school picture, right? Back when you're a little guy or a little gal, they had this, and you'd have to take a class picture too, because that was the best, right? You got to dress nice for class picture day. It's going to be awesome. Okay, so I want you to think about this. And I'm going to lay out 2 ideas, right? Because what's not down here is like row 1, Sally, Sue, Aaron, whoever it is, right? All the names, none of them are there, because I want to use this idea and talk about how can this be a relation. Okay, so let's say, right, because I only see one teacher here, right? One teacher. So let's say the teacher has student 1, whoever that is, and the teacher has student 2, and the teacher has student 3. Right? So that's what's happening, as we say, kind of the relationship of what's happening in this. What is it? This is class 1 through 3, back in Queens. Don't look for me. I'm not in there. Okay. All right. So if I give you this set of ordered pairs, is that a function? Okay, not sure. Let's take a look at the map. So my domain consists of the teacher, and then I have student 1, student 2, and student 3. So I have this, and whoa, we haven't seen this before. Okay, so when I see this out of my domain, then this is a relation only. And when I say that, we're saying this is not a function. Whereas if I want to fix this, I can make this super simple. So student 1, who do they have for a teacher? Teacher T. What about student 2? Who do they have? Teacher T. What about student 3? Who do they have? Teacher T. All right, so student 1, student 2, student 3. And there's my domain. Here's the teacher. 1 arrow, 1 arrow, 1 arrow. So this is a function. So I know we're dealing with a couple different ways to look at this today. But hey, that's our task, right? And we don't back down from a little challenge to try and figure some things out. So this is what we got. So that's how we can tell from the map, and also as we look at the domains, right? I knew right away because this domain repeated that domain, and I had a different student for those, so that wasn't going to happen. All right, so that's if we get ordered pairs. What if we give you an equation like this? Well, one thing I could do is I could make a table. All right, let's put in 0. 2 times 0 plus 3, well, that's 3. Let's put in 1. 2 times 1 plus 3, 2, 5. What if we put in 2? 2 times 2 plus 3, well, that's 7. Well, those look okay, but the problem is I can only tell based on the numbers that I put in here. So what I'd like to do is take that and put them on a graph. So 0, 1, 2, 3. Right? Remember how to plot points, x and then y. So 1 gets me 5, and 2 gets me 2 more, 7. And now I can say, you know what? If I plugged anything in between there, this is what happens. Well, look at that. That turns out to be, oh, you guys knew that was a line, right? This is mx plus b, right? This is a linear equation. Now, when I have the graph, right, the whole point was to get the picture. When I have the graph, what I want to do is I want to make a vertical line, just like my pen right here. Right? So we're going to just keep that vertical line and say, boom, there it is. So we're going to perform the vertical line test. And I'd venture to say that my vertical blue line hit my actual graph once and only once. So that's the vertical line test. And if it hits once and only once, that means, yes, this is a function. Okay. So I'm going to go through and, we're going to make some graphs here, but eventually we're going to skip over those and we're going to say, hey, you know what? I could do this without any of that. So let's get an idea of what some of these basic functions are. Some things hopefully you've seen, maybe you didn't, maybe it's been a day or two. All right, so let's plug in -1, 0, and 1 for my x values and see what we get for 1. So what's -1 squared minus 4? -1 squared is still 1. So that's 3 minus 4, it's -1. I'm going to go ahead and put that on the graph as well. So -1 gives me -1. Let's plug in 0. 0 squared is 0. 0 times 3 is 0. Minus 4 is -4. 2, 3, 4. All right, we got that one. What's going to happen when I plug 1 in? Well, it's going to give me -1 again, right? Because 1 squared is 1 times 3 is 3. It's -1. All right, so what happens is I should get a nice U shape out of this. If I continue doing more ordered pairs or checking more x values, I'd see more of it. Okay, so when we get into this idea of what it looks like. All right, let me get my blue highlighter. I'm going to perform the vertical line test. It hit once and 1 only once. So what's that mean? This is a function. Okay, so that's a good thing. All right, what about this absolute value? We've been talking about this one just a little bit as far as how to work with it, but what's the graph itself look like? So again, if I'm not sure, and you'll do this the whole way through all your math career, -1, 0, 1, let's just plug in a value. So what's the absolute value of -1? Hey, it's 1 plus 1 gives me 2. Absolute value of 0 is 0, plus 1 is 1. And the absolute value of +1 is still 1, plus 1 gives me 2 again. So let's take a look at it. So 0, 1, -1 gives me 2, and +1 gives me 2. And this will continue to make a V shape as we deal with the whole thing. All right, so blue highlighter, it hit once and only once. What's that mean? Yeah, we have a function again. All right, now these are a little bit different as far as the domain and range because it's not limited to just the numbers that I picked here. So I left that question off for just a little bit here, but now it's time to cover what's going on here. So as I look at my domain, I notice that this parabola is going to go to the left and to the right, this U shape, forever. So that means my domain is all real numbers. Same thing happens with my absolute value. It's going to go left and right for a really long time. So we use that capital R merged up with like paragraph signs. So we say all real numbers. Now, what about the range? I notice both of these only open up. So that means the Y value has to be greater than or equal to some number. So what I'm looking for is what's the very bottom of each of these shapes. Okay, so I'm going to draw this horizontal line. Just say that's the very bottom of it. Okay, so remember this one, it was down 1, 2, 3, 4. So I start at 4, and all of my Y values are going to increase from there. So that means I'm going to use -4. But where did this one start? On my Y value, hence the horizontal line, at 1. So all the Y values are above, greater than 1. So we can get those done with. Now I skipped over this question with our line up here because I do know that this graph is going to go left and right forever. So that's all real numbers. What about the range? I also notice it's going to go down and up forever. So we get all real numbers. So anytime we have a diagonal line, that's going to happen. Okay, so what throws us off is, of course, the zero slope. Right? So our vertical lines and our horizontal lines, that's going to throw us off for domain and range. All right. Hey, quick review. Which one's not a function? Ready? 3, 2, 1. Right. Here's what I'm checking. All different. Okay, that one's okay. All different. That one's okay. Uh-oh. Okay, remember, I don't say that it's not a function until I double check the Y values, right? Because 10, 2, 10, 2 would be okay. That's those 10 hot dogs for $2. That would be awesome. Okay. So this one is our answer because this was written in the negative. All right. We're going to go back to that vertical line test. Here you go. Boom. 1, 2, 3. Is this a function? No. So what do we call it? A relation. Here we go. Hit it. 1, 2, 2 times. Went through the circle. Is it a function? No. What is it? It's a relation. Okay, so you can say not a function, but technically it is still a relation. All right, so that's a good chance to take a break if you need one. So you can pause and come back, but make sure you come back because we need this part as well. All right, hey, welcome back. If you didn't take a break, that's on you, not me. I told you to take one, okay? All right, I'll shut up now. Here we go. So before, what you were told is, okay, here's the equation, y equals negative 5x plus 7. Easy enough. I said, okay, could you please, I said, please remember, evaluate if x is negative 2. So what would you do? You'd say, all right, teacher, negative 5 times negative 2 plus 7, I get 10 plus 7, I get 17. Cool. Now we're going to cut out all this extra writing, and this is exactly the way you're going to see it, most likely for the rest of your math career, at least in high school. All right, so now instead of saying y, I'm going to call it f of x. So this is the function f, and x is x. But now I want you to evaluate the function f when x is negative 2. So I'm going to replace x with negative 2 and then proceed. So that gives me 10 plus 7, so I get 17. How'd you get 17? Well, I took function f and I plugged in negative 2. Okay, this would provide me with the ordered pair. This is getting pretty far along here. So if I put in negative 2, I get 17, kind of that function machine that maybe you learned about somewhere in middle school, of how we evaluate those functions. All right, next one. Function f, so note it's different this time, but that's okay. We want to replace x with what? With 4. So I need 4 squared plus 2. There's another x. What do you think I should put in this time? 4 again, minus 5. All right, so I need 4 squared, that's 16. 2 times 4 is 8, plus 5. All right, 16 plus 8, that's 24, plus 5. Ooh, why did I make it plus 5? Goodness gracious. Must be after lunchtime here. Minus 5, minus 5. Good thing I didn't went in this order. All right, so we get 24 minus 5. I believe that's 19. How did we get that? We took the function and we evaluated it at 4. What ordered pair would it be? 4 comma 19. So we get all those ideas. What about this one? Oh my goodness, it's blank. I'm just kidding. It's not really blank. I figured we could make one up together if we were together. But, you know, COVID happened and here we are. So let's go with 2x squared minus x plus 5. So again, I have multiple places. Let's not be done. Let's put it over x plus 4. Oh my goodness. Anything else? Nah, let's leave it at that. Okay, what do you want to evaluate it for? Negative 3? All right, I'm done with that. So that means we're going to evaluate this function. We're going to put every place that there is a x, we're going to put in negative 3. Notice it's squared minus negative 3. Well, that looks intriguing. That should be interesting. Negative 3 plus 4. All right. So what do we got on the bottom? That seems like the easiest thing to do. Negative 3 plus 4, that's just 1, right? So I won't need that in the end because dividing by 1 is going to give us exactly what we had. Up top here, I get 2. What's negative 3 times negative 3? Well, that's 9. I see minus a negative. Remember we said that was intriguing. Remember, minus a negative means plus 3 and plus 5. All right, before I can do any more addition here, I need to finish my order of operations, which means multiply. So I have 18, right? 2 times 9 is 18, plus 3 plus 5. It's over 1. You know what? I'm going to stop writing that because we don't even need that. 18 plus 3, that's 21, plus 5, that's 26. So 26 over 1, or just 26, becomes our final answer. Not too shabby. All right, so the other thing I can ask you to do is do multiple of these and then do what? What, there's more? Yes, remember I told you to take a break. I knew there was going to be more. Then I want you to add the two answers together. So let's go through it. So f of x, right? We want this one for 2. 3 times 2 minus 2, that's 6 minus 2 is 4. All right, g of x, we're going to evaluate this one. 2 times -3 plus 5. So that's -6 plus 5. Well, that's -1. What am I supposed to do with these two answers? It says 4 plus -1. I want you to add the two answers together. So my final answer is 3. All right, not too bad. So it's kind of just like coded together. And we're learning a little bit of mathematical language of what to use, where to use it, and how we're going to do that. Okay, so pretty good. Got an exit pass on here. If you can try those out, then I'll be able to see before you come into class that we are in good shape. If you're not in my class, hey, thanks for watching.